LGBT for Nigerian audience. I wouldn't show them side internet.
Yo. Hi. Yeah, what's up? I can hear you. Let me just call out that guys. The link I just sent. This link I just sent.
Well, what's your experience?
Yeah, I just sent you a new link. Yeah.
What's up, Jay?
I'm good.
Hello, are you ready?
Yeah.
Are we ready?
We are ready in the next 15 minutes. You guys should join the meet. I just sent the new Teams link.
You just sent the link. Yeah.
Use that to join.
Give me a minute. Right. Oh, shoot. Okay. Oh, I forgot to switch the lights on.
Well, I'm not trying with the camera.
Let me see.
Just use that.
I'm joining the meeting.
All right, no problem.
Yeah, it's fine.
So,
the maturity time is like 2 years.
so Hariharan. Yeah. Hariharan, I just shared you a link. That's what people used to join. Hariharan, can you hear me? All right. Yeah, I can see you, Abdullah. Yeah.
Wait, why can I not show my camera?
Why? Okay, let me share. Let me change settings. Your camera is not going on at all.
Like this guy. All
right, let me save it. You should be able to allow your camera now.
So it's mostly
Minecraft, the OG.
Awesome. Yeah.
What's up, man? How are you?
I'm good, man. I'm good. Nice to see you, bro.
Nice to see you too, mate. All right, let's go.
Yeah, this is the first time.
Yeah, first time meeting. Yeah, where's Tega? That's his name,
yeah? Yeah, he'll join. Yeah, Tega is coming.
Mate, can you send me this PPT that you're using? I got a Google Chrome, man.
Oh, okay. I sent it to you in your WhatsApp already.
Yeah. You sent it to me as a Chrome, like a Chrome document. Can I get the PPT document?
I sent it as a PDF. Okay, all right.
Yeah, exactly.
I'll send that.
All right, cool, though.
I'll send that.
All right, just to make sure, yeah. Okay, wait. After you send it, I'll.
MLSAs is April.
Okay, let me send it on the group.
So I'm just going to post the. I think you are presenter, right? Already included your email anyway.
Oh my god, I hate checking my email, man.
Let me see if I can.
Give me a minute, yeah.
Okay. I'm gonna make you a presenter. So. Have you seen the? I've made you a presenter, also.
Oh really? Oh, okay. Give me a minute,
yeah.
All right.
Hello.
What's up?
Okay, I'm being hacked.
Okay.
Yeah, I'm good. Are we turning on our cameras?
Yeah, welcome.
Good, mate.
Yeah,
Yo,
we're putting it
Faith,
on for sure.
Yeah, I'm coming. Wait up.
Could you please send me the file, man, on WhatsApp?
Yeah. Let me enter PowerPoint and get it.
You send me now. Send me. Let me join.
All right.
All right, let me send you that.
What the?
I'm going to share you the PowerPoint stuff.
Yeah, my computer's glitching, mate.
Oh,
yeah, I
shit.
received the email, though. I received the email. Yeah, no, I'm
Alright,
good. I'm good.
alright.
Let's go.
Sent it to you.
So
I'm gonna send you the PowerPoint file now.
yeah, send the PowerPoint. I just want to make sure I'm talking about the right slides, yeah?
Yeah. So
Yeah,
let me
I'm waiting for.
see
Let me post it on my WhatsApp status too.
Because that is good.
Yeah, just post
There's
it.
no other place. Join up with us.
Yeah, I never use WhatsApp status, man, so I'm new to this.
I said that is without.
Oh, okay.
My status, okay. Okay, I did it.
All right. Let me download the copy.
All right. Boom.
All right.
Yeah, done.
Awesome.
Have you sent it to me?
No, I'm still downloading it. I'll send it to you now.
Okay. All right. God damn, my alarm.
Yeah. Hello, Adorable. Yeah, I'm fine. How are you doing? Good afternoon. I'll send you the link.
Oh, are you talking to me? But you muted. Mate, you're muted, yeah? Just letting you know.
Hello, bro.
Hello, what's up, man?
Oh, just a minute, just a minute. Yeah,
Sure, yeah, take your time.
sure,
But
bro.
let's go.
Give me a minute.
Tega in the flesh.
Welcome, Tega. I'm coming.
Welcome.
Merhaba, Abdulla.
Yeah.
Welcome.
Marhaba,
Nice to
man.
see you.
Hello, Faith, bro.
I do.
Yeah.
Hey.
Capybara, baby. All right.
So, yeah, I think that's downloaded finished. Yeah, share your screen.
All right. Yeah.
Okay, no, I'm not talking to
okay,
you.
the slides are here.
I'm
How
coming.
many
Give me a
attendees
minute.
do you have now?
Here. That's cool. Oh, you can. Oh, you can
You should be
navigate
able
the slides.
to
That's
access.
cool.
Yes, you can navigate the slides, so you should be able to access it. I just made all of you presenters. So, Hariharan, can you share
nice.
the join link to the group? Oh yeah, you click
Right.
it.
Ooh.
No, your voice.
Okay. Yo, Faith and Tega. I'm just making sure. I'm.
Show that joining as a guest, and then it will redirect back
Yeah.
to. Can you see? It will
Wait. Yeah. I'm taking over slides 7 to 9. Yeah. Tega.
Okay.
Yes.
Yeah.
Yes,
Okay.
yes.
Let me check it out.
8, and 9. Yeah. It's right here. I think you can navigate the slides through this. Are you a co-host as well?
Yes. I made everybody a presenter.
Perfect.
So you guys can navigate the slides.
Yeah, Tega, you'll be taking over slides 10, 11, 12,
All right.
13,
Go back.
and 14. Yeah.
Okay. All right. That's fine.
Yeah, and then I'll be taking from slides 15 to 19. applications of Copilot Studio.
Okay.
15, 16, 17, 18, and 19. Yeah, and then, bruh, I don't know who's doing this. I think it's Faith.
What's that?
David.
I'm
Building
going to
your
take
AI
the Copilot
agent.
Studio. Yeah, I'll take all those parts.
So you're
take
taking over
Copilot
from here,
Studio.
yeah? From
Yeah, I'll
slide
take
20.
over from the Copilot. Yeah, from slide 20.
Yeah, so I'm
Take
doing
over from
these,
there.
right?
Yeah,
Like the
yeah, you're
applications.
doing. Yes, this is it. Hariharan will be the one to introduce everybody.
Yeah.
Understand?
Yeah,
Hariharan
sorry.
will introduce everybody, all the slides. Yeah, just
Okay.
Hariharan will
Yeah.
introduce
All right.
everybody.
So 15 to 19, I'm taking over, yeah? 7 to 9 and
Yes,
15 to 19.
yeah.
Just let you know.
Yeah.
All right.
Yeah.
Okay,
So,
perfect.
that guy will come in,
Sure.
is going to introduce, he's going to take him after this introduction, after you, Abdullah, does this introduction to AI,
Uh-huh.
what AI is
Yeah,
used for,
yeah.
blah blah blah.
Uh-huh.
Then
Exactly. Then
that guy will
Taylor.
come in to take in the models and the more technical part of it.
Exactly. All right.
Yes. So then when he's done with the models and large language models and everything, you would come back in. Tega, you're going to have more than by slide this is not as much as what you're going to actually talk about. But you'll be able to take that, right? You'll be able to handle that, right?
No, sure. I might go outside the scope of the slide also. Like not everything on
Definitely,
it.
yeah.
Right, yeah.
Yeah, so go outside the scope as much as you like. So once it comes to this place, build with Copilot. Yeah. So Abdullah will come back in.
Yeah, I'll come back
Mr.
to
Bullet,
the applications, yeah?
Yes,
15.
you come back in
Slide
here.
15 here.
I'll Copilot.
Where
Yeah.
is it? This
So-
one. Building. Yeah,
so,
these are like
yeah.
just applications. All right.
Yes, you speak to this place, then
Uh-huh.
from here I enter. I come back from here and I
Understood.
take the
Understood. Yeah,
events. I will make it an interactive session from there.
yeah. Okay. Yeah. Yeah. All right.
All right. So
Yeah,
I
and then
think
from
Hariharan,
here,
you
you're
can.
just taking over, yeah?
Yeah. Oh,
Yeah,
Hariharan
alright.
is not on the call. I'll give him a call so you join.
Okay. I'll
Hariharan has
just go to
joined.
slide 1.
Hariharan. Okay.
Where am I?
Well,
yeah, am I audible?
you guys.
Yeah,
All
I
right,
can hear
welcome.
you.
No,
We can
Hariharan,
hear
you're
you.
going to be doing the introductions.
Yeah, I'll take care of
You're going to be doing the
introduction. Okay.
introduction.
Yeah, I have to introduce you guys, right? That's it, right? All right, I'll take care of that.
Okay, what's that?
Okay, I'll just roll out this
All
link
right,
in the
Nick.
group so that everyone could join.
All right, yeah.
Okay.
Yeah.
To show you how crazy it can be. I just
Yeah, guys, they'll join in a few minutes. So we'll just wait for them.
Sure,
Is it
okay, okay,
fine
no
for
worries.
you? All right.
Hariharan, can you please share the link on the group so that everybody can start joining?
I think he already shared it.
Okay. All right. Good start time.
Hello.
We'll be starting soon. All right. I want more people to
All
join.
right.
So once we hit 15 people, we start.
All right, cool, no worries.
All right, everyone, we'll start. I'm waiting for a few more people to join.
Sure, we'll wait for a couple of minutes and then we'll start.
Yeah, definitely.
All right.
All right, the numbers are climbing. Yeah, awesome. We are getting there. More people are joining.
Guys, we'll start the event by 7:06. So stay tuned.
We'll start the event in 2 minutes. The meeting will start in a minute. All right, the numbers are climbing. So, Hariharan, are you there?
Yeah. I'll start.
All right.
Right. Are you guys ready?
Can show yourself. Yeah, you can show yourself. Awesome.
Okay. So, good evening, guys. I'm Hariharan, President of TEDx. It is my absolute pleasure to welcome you all to this exciting Microsoft Learn Student Ambassador event. Today, we gather not just as tech enthusiasts, but as an eager community. A special and heartfelt welcome to our guests, Faith David, Abdulla Harees, and Tega. Their expertise, dedication, and contributions to the community are inspiring. Each of them brings a unique perspective, and we are honored to have them with us today. Technology is evolving rapidly, and even like these, give us the opportunity to stay ahead, exchange knowledge, and build connections. Whether you are here to deepen your skills, seek career guidance, and simply engage in thought provoking discussions, it promises to be insightful and valuable. Once again, thank you all for being here. And a huge thank you to Faye David, Tega, and Abdullah for joining us today. Let's make this a session to remember. Welcome and let's get started. Thank you.
Thank you very much, Hariharan. And we from the Microsoft Learn Student Ambassador community, we have really appreciate this collaboration. All right. So, before we start, I'm going to just say a few words. I am a student of Obafemi Awolowo University. I am a better Microsoft Learn Student Ambassador, and I write .NET C#, and I do a bit of music. And this is another event that we're hosting in the year 2025, and this event is targeted towards AI, and wants to take you from the foundations to all the cool stuff that is happening in AI. As my co-host too also introduce themselves. Ogehenetega, you go first.
All right. Hello, everybody. My name is Ogehenetega. You can call me Tega. I'm a machine learning engineer and also a Microsoft Learn Student Ambassador. Yeah, I finished them last year. Yeah, that's about me. I'll be taking you through some foundations of artificial intelligence and comparing traditional programming to AI now used. I do.
All right, awesome. Awesome. Thank you very much, Tega. So, next person to introduce himself will be Abdullah. Abdullah, please can you?
Hello, everybody. My name is Abdulla Harees. I'm a fourth-year software engineer studying in Turkey, and I'm a Microsoft Learn Student Ambassador, Beta. Represented Turkey. I'll be teaching or talking about the generative AI and applications of Copilot Studio in this presentation. So I hope you all get something out of this presentation. I'm looking forward to having a successful presentation with you.
Awesome. Thank you, Abdullah. So today, being a Saturday, I first of all would appreciate everybody that made it to this event. It's not easy to take time off to come around and say you want to learn something. And I know some of you are beginners, I know some people are experts, and I know some people are intermediate. And well, having all this range of skill levels, I'm sure that there's something for everyone to learn today. And this is also a shout out to TEDx community in Chennai, India, for also empowering us to come up with this series. And welcome to episode 8 of the TEDx Beats Chennai event. Anyway, so the title for today's event is AI Odyssey, from foundations to frontier innovations. The reason for this topic is because AI sometimes seems like a fantasy. And it being a fantasy, a lot of people feel estranged from the concept of AI. And that's what we're going to be breaking down here. And not just breaking down the concept of AI, we'll also be looking into the applications of AI so that you can also understand how did AI come about and where AI is going and what can I do with AI even as an individual. So off to Abdullah, whereby you'll be taking over the event from here. Thank you.
All right. Hello, everyone. I'm really excited to welcome you all today. We're about to take a fascinating journey into the world of artificial intelligence. AI is everywhere around us, shaping the way we live and work. So today we'll explore how AI is transforming our daily lives, the models that make AI work, the rise of generative AI and how it creates amazing things. And finally, we'll get hands-on experience with Microsoft's Copilot Studio, where you can build your own AI tool. So let's get started. In this session, we'll learn about AI's past, present, and future. More importantly, you'll discover how you can use AI to create something amazing yourself. So here is what we'll cover today. AI in today's world. So we'll look at how AI is already a part of our daily lives. The core of AI. We'll break down the models behind AI in a simple way. The rise of generative AI, how AI can now create art, music, and even write content. And finally, hands-on with the Copilot Studio. So you'll see how AI tools are built and even try making your own. So it sounds exciting, right? So let's dive in. AI is all around us. Even if we don't always realize it, it's working behind the scenes in many of the applications and services we use every day. For example, streaming apps like Netflix and TikTok. They recommend shows and videos based on what you like. Email services like Outlook and Gmail. They filter out spam and even suggest replies to your emails. Voice assistants like Siri, Alexa, and Copilot. They help answer questions like, what's the weather today, etc. And music apps like Spotify. They suggest songs that you might enjoy based on your listening habits. Now, I'll just pass it on to Tega, who will talk about the foundations of AI.
All right then. Thank you very much, Abdullah, for the warm introduction. Okay, so I'll be walking us through how models or how AI actually works, so how they think. You might be wondering, I'm sure a lot of us here have made use of ChatGPT or Claude AI or Microsoft Copilot and so on and so forth. But then you'll be wondering, how does it know how to give a response, or how does it know the answer to my query? How does it know how to do things like this? Or probably you've used DALI or Microsoft Designer, and you ask yourself, how does it know how to come up with images? How do computer even understand images to begin with? So I would like to start. I'll try to walk us back. I don't know if you can see the presenter. So let me just sync so that when I change the slide, you'll know when I've moved. All right. So by the way, what I've mentioned now, those are generative AI because they are creating new content out of just the prompt you give it. So those are generative AI. But I want us to take a step back to how we got here. So I'll talk about traditional programming first. So say, let me start with an illustration. You want to build, let's say, a robot, a digital robot that finds the fastest way, or no, that finds a way to like move away from obstruction or go through corners or move around. Previously, as developers, what you do is that you create conditional statements. Now, for those of us that are not programmers in the house, conditional statements are, say, the way you make your decision. When you get out of bed, what do you want to do? Do I take my bath, or do I do exercise? So that's like a conditional statement. It's like a if else. When I wake up, what would I do? Should I take my bath, or should I work out? So for that robot analogy, the programmer will go there and tell the robot, right, okay, move 10 steps. Now, when it comes to an obstruction, or when it meets an obstruction, in the code, you have something like, okay, if we get to an obstruction, move. But then that is very, very vague. In programming, there's something called specificity. You need to be specific about what you want to do. So obstruction could be anything. It could be a screen, it could be a keg, it could be a roadblock, anything could be obstruction. So you see, you need to take account of those many things that could be an obstruction to that our imaginary robot. So then you have that then first, then say, okay, if we come across a keg, turn left or turn right, do this, do that. Now that's how traditional programming will work. You specify the how, so you specify the what, how would that thing accomplish that task before you get a response. But when it comes to AI, yes, you give it a what do you want it to do, but the how, you leave it up to it to figure out. So you don't need to like tell it there's an obstruction here, or you don't need to give it those how that we're given the traditional programming. But then you'd ask, but I thought computers were dumb. How do they know, how would they know an obstruction? And that's where the AI comes into play. So in the definition there, you see AI models are like recipes. Data goes in, rules mix it up, and smart decision comes out. Now I really like this definition of what AI models are. So you have a model. How do the model know these things? It's just like when we were little. You went through preschool, then high school, then college and all. But what were you doing there? You were learning. Now, I'm sure the teacher did not tell you what, let's say 27 times 27, but you know how to calculate 27 by times 27. That's because you already have the enough data to actually do that kind of calculation. You've been taught what 2 times 2 is, you've been taught what 4 times 4 is, and so on and so forth. So you've actually learned a pattern. And another definition of AI is just human intelligence in machines. So they are mimicking our own intelligence, but machines are the one doing the mimicry. So human intelligence in artificial intelligence, just like the way we learned. We also, oh no, AI are like us, not we like AI, because we came first actually. So they learn through data. The data we used when we were growing up, same data you give to machine. But the benefit of machine, or one of the advantages, that they are much faster. I mean, when you study computer, one of the only things you learn is that computers are very fast in processing. That's one of the benefits of using a computer. So now couple that processing speed to the data that would normally learn ourselves, and giving it that would give you this model. So like I said, the data goes in, the rules mix it up. then it gives you an output. So they are trying to spot patterns, like we've said earlier on. Then example, feed a cat rather, or a data or a dog picture, and then it learns to tell them apart. We'll be taking like a quick look on how large language models work. So maybe that would give us more granular understanding on what that is. But let's go through to the next slide. All right. So neural networks, please, if you have any question as I'm talking, you can just raise up your hand, so I'll answer it. It should be an interactive session, so you don't need to be muted all along. You can just bring me back if there's anything you don't understand. All right, then. I should be able to share a whiteboard. Hold on one second. If I can share that, I'll share the one I have here. So let me know when you can see my whiteboard.
Yeah, it's still coming up. Board is up. The whiteboard is up.
Yeah, can you see it?
Yeah, the whiteboard is up.
It's up? All right. All right, perfect. Now I just want to like give an illustration of, before we go into what deep learning actually is, which is the crux of generative AI. Here for this event, we'll be giving just like the surface explanation, because if you're really interested in artificial intelligence, it's going to take you more than just 1 hour, 30 minutes or 30 minutes of my time to explain that. You need to, but I just want to give a foundation, so you're no longer surprised when you interact with these models out there in the world. So just to confirm one more time, you can see my screen, right?
Yeah, I can.
All right.
Yeah, we can see it.
Yeah, beautiful. All right, then. Let me change this to white and have the border. So look at, I want to draw a picture real quick. Then we'll take our explanation from this. Beautiful. So in the outer circle, we have what we call artificial intelligence, AI for short, AI. Then within this, we have what we call machine learning. I'll abbreviate it to ML. Then within this, we have what we call deep learning. Now, we've touched on artificial intelligence. We said it's the mimic, or the ability for a machine to exhibit human intelligence. Now, that is it. But how do they exhibit this? How do they know how to exhibit this human intelligence? Now, we come down to machine learning. Now, recall I told you that we have the data. We're going to have data here, then an algorithm here, then your response. Use this for response. So this will be data. Let's say an algorithm. Okay, just to get a pulse check, how many of us are studying anything related to maths here? If you're studying mathematics, you could just signify. Just doing a pulse check to know if you're following. Anything related to maths, computer science. Minimize this. No one. All right, I can see Ola. All right, that's fine. That's fine. I just want to get the check. I'd have loved us to take a linear regression problem, but that's fine. Okay, so we have the data. This is what the machine will learn. But how does it learn this? That's when we have the different algorithms for it to learn those patterns. Please don't forget, the most important thing is that this pattern, it's not memorizing. That's the difference between traditional programming and artificial intelligence. While traditional programming, you are the one telling it, giving it the answers. It's more like you're writing an exam. But instead of you to learn, your lecturer is giving you like the answers during the exam. So I could ask you, what kind of car is this? Are you looking at? Then me as a lecturer, I'm also telling you that, oh, if they ask for this, write this down. But AI, it has to learn from the data. So your studies, maybe from your first year to your fourth year, you learn all those, then you bring it out in your final year in your exam and all. So that's what this algorithm tries to do. And a different form of algorithm. Mind you, we're talking about machine learning now. So in ML, you have things like linear regression, that's for predicting, that's for predicting. Then you have classification for images and so on and so forth. Not to get too technical there. All right, so that's this guy here. But now for deep learning, now this is where we now have things like neuron that you saw on that slide. I'll drag and drop an image here to show what the neuron is. So I'll put this here. All right. So now this, theoretically, this is how the human brain, well, more than this, we have billions of neurons in our brain, but this is how the human brain is structured. And I'll prove that to you. Like I alluded to earlier on, when we were younger, when we wanted to learn something, we're shown a concept. Say we want to learn what fruits are. We are shown an apple. That apple goes through the input. And then inside the hidden layer, some computations are done so that we can recognize an apple later in the future. Or say I see a small green and a red apple now. If I'm showing a bigger one, I'll know, okay, yeah, this is still an apple. So within this does they do some calculation. Don't forget, when dealing with computers, there's always numbers. So you're dealing with numbers here. All right, so does some calculation, then gives like a prediction and output. Now during the training phase, it just learns this, and instead of this output here, it's going to give a prediction and then compare it with the original to know if it's truly learning. If it's not, we'll go back to the hidden layer, make some adjustment to the weights and bias, and give an output. But yeah, that's during training. All right. So now this is deep learning. This is simple machine learning. Now you ask, what's the difference between deep learning and machine learning? All right. So in machine learning, you can predict what it's going to give out. Like you can solve the kind of computation it is performing within its algorithm stage. Now, I told you about linear regression. Actually, linear regression is something like y equals to ax plus b. I'm sure you've seen something like this kind of formula before in maths. All right. So say my slope here is, let's say 10. All right. And my intercept here is say 5. All right. So say I'm predicting the price of a property, and y is the price, and x is the current is the area of that land. So I'm giving this as 10, my slope as 10, and my intercept as 5. So I'll say, okay, so when the square meter is about 200, what will be the value of y? All right, so it's a simple 10 open bracket. We said 200, right? Plus 5. Now, I'm going to get a response. I'm going to get an output of y is equals to this 2005. So see, let's just use dollar, since there are a lot of countries here. 2005 dollar. So now you can see that I can actually do what this say just what this linear regression algorithm is doing by hand. I can predict this. But the thing is that what it's learning actually is learning the value of this A and then B, and not just to predict an output like this. But I just gave this as an example so that you can tell what this is doing. But when it comes to deep learning and you want to predict that same thing, you're not just going to give it the value of, you're not just going to give it like the square feet, the area of the land as an input. You can give it things like the location. You can give it things like the what else comes into the factor? Okay, maybe inflation rate and stuff and all. Now you are giving that as an input. It will give an output, but what is happening here is like a black box. So that's what I'm drawing. That's what I'm alluding to. While in deep learning, you can understand the computation is doing in order to understand the pattern. In deep learning, the hidden layer that does the computation is sort of like a black box. Yes, you give it the architecture to use, but how it learns those patterns to get the weight and the bias is kind of like a black box. Do you understand? It's kind of like a black box. So you don't really, it's more like the way the human brain works too. So I see a fruit. I can't really tell how I remember or how I know that this is an apple. I just know that from the shape, I don't know how it's registered in my brain, something like in that way. I don't know how it's registered or how the neuron is seeing it and it's telling me that this is actually a fruit and it's an apple, a red apple and all. So similar to what it's doing here. So you can see why I said that where it's just trying to mimic what the human brain is, how the human think and all. That's why you see the deep learning is actually closer to what I defined AI to be. All right, because this is more complex. When you're working with images, you're working with LLM. Okay, now I think we can go on to LLM. But before we go, I want to make sure that we are on the same page. So we'll just talk about generative AI. Because if you have any questions, if you don't want to mute, you can
unmute yourself if you have a question, or if you want to talk about whatever you have observed from the little lecture you just gave. Anyone in the audience who wants to ask, maybe you don't fully understand what machine learning is and you still want to go over it again, or you don't understand fully the difference between deep learning and machine learning, and you want to go over it again.
All right, there's a hand raised up. Martin, you can unmute yourself, or if you want to drop it in the chat, it's fine also.
All right, thank you very much. So, where I'm not really clear, I think the initial examples you gave explaining what AI is and how AI, came about, the fact that there's human intelligence and there's artificial intelligence, and you're trying to break down artificial intelligence into its niches. So, when you got into ML and that's machine learning and
deep learning.
Deep learning. I'm still not very clear, especially with the deep learning. The machine learning part, I understand that it's more of mathematics using functions to automate bots or systems in that sense to give an output. But the deep learning, I don't know, I don't really understand. And then if you can also, after explaining that, do a relationship again between deep learning and machine learning, I think that should help. Thank you.
Okay. Let's go over this particular example again. This particular example. Let me just delete. Delete. Wait 1 second. It's not letting me delete. All right then. So I said for machine learning, you have the data, and then you have the algorithm you want to use for making a prediction. Or you have the algorithm you want to use to train a model. Actually, this should be a model. Let me draw the third box. I'll draw it down here. All right. I'll call this, I'm working with numbers. Let me call this linear.
I don't think we can see what you're doing. I can't see what you're writing. I think that's where I really love you, because while you're explaining, I was
Should I stop sharing and share again?
Yes, probably you should do that.
Okay, stop sharing.
It's a close game.
Can you see my screen?
No.
The screen is coming up.
Yeah, okay, now we can see it.
Yeah. All right, beautiful. How about Martins? Can you see my screen?
Yes.
Hello?
Yes. See.
All right, beautiful. Okay. So you can forget about this. Let me drag this away. Let me try and move these guys away also. So we'll take it one at a time. All right. So how do we create a model? Now, okay, I didn't mention what a model is. So a model is just mathematical, what you call computations. So that's what is actually doing the predicting. Once you train, what you're training is that you're training a model. All right. So you have the data, you have the algorithm you want to use to
Tega, can you make that concept of a model more, everyday, like use it everyday, like example that you said that.
Okay.
Feeding data into
What can I use?
Just use probably cooking or anything.
Okay. All right. So you have the data. You have the algorithm. Now, the model, like I said, was a mathematical computation. So let me use something like cooking as an example now. I don't know what's a collective food we all know here. I think rice. Rice should be a common food now.
Yes, rice.
Yeah. Okay. I hope this analogy makes sense. So you want to cook rice. You put how do you make rice? The water, the rice itself, then the salt. Now you can think of that salt and everything as that process where the fire and everything is boiling as the training process. Then the salt and everything you put inside is the algorithm that you're using rather. Then what your output is now the model. I'm just trying to think of how to relate it to predicting more things. But yeah, you get the analogy now. What you get out and the output of that. So those the raw rice you use is the data. Hello?
All right, yes, the raw rice is the data.
Yeah, so the spice and the spice, then the process, the heat and everything is the training that gives you the final output as a model. I hope that makes more sense. But I want us to be a bit technical about it, that there's just computation. so that when you want to predict, you'll not be thinking about rice, how you use rice to predict or stuff like that. But yeah. All right, so this model has learned a lot of things through the training process. That's what I was alluding to. That's why I just called it a mathematical computation, because it learned patterns. Like I told you that most of the time, what is in the linear regression, the formula I gave, what it's trying to learn is trying to learn the slope and it's trying to learn the intercept. In mathematics or in statistics, this is like the general formula for linear regression, or even the formula for finding a straight line. Because what you're trying to fit it through a trend. You're trying to predict a trend. If I draw a chart here, and say my data points are at different, they are scattered around. What I'm trying to predict, I want the output to follow this particular trend, or if the trend is like this, follow that same trend. So something like that. But yeah, that's besides the point here. How do I? All right then. Okay. So we have the model. We'll run this. If one is doing the comparison between what is generated and the actual data, that's the testing phase or the validation phase. So when you're training your data, or when you're training your model rather, you have to split your data into about 2 or 3. The standard, well, there's really no standard, but you can have 3 or 2. But for learning, it's just to testing and training. So you can have like 80% of your data for training and 20%. The purpose for the 20% is so that you can check if it actually, or the model can check itself if it actually gets it. Because I told you it's trying to learn a pattern. It's trying to learn, how do I get from here to here? How do I get from here to here? So say you have the number 5 in your test, but it predicted 6. Like it would be like, oh, this is not quite right. You can calculate the mean absolute error. And that's a way of finding the error between the predicted and the actual value. If it's like, oh, there's something wrong, let me learn something, and so on and so forth, to run this multiple iteration before you get this particular model. I'm trying not to delve too deep into training, because there might be a lot of things there's a lot of things that I need to tell you before we grasp that concept. So I'll just talk about this in high level. All right. So sorry if I don't get too overly technical. But do we understand what model is? That's what I want us to understand. If we can understand it, then we'll understand deep learning. All right, then. So now with this model, I can then use this model to generate or to predict something that was not in my data set. You get? I can use it. This model has not seen, say I want to predict the price of houses now. Okay, yeah, that was the example we're using. The price of houses. Now, the price of houses, let's say for 200 square feet was about 2,000, for 300 was about 2,500. Now, those data points were already in our data. But say I wanted to predict for 5,000 square feet. Now, you would say that you can probably do that with normal computation. You can just get a unique formula for that and do the prediction yourself. Exactly. That is what this guy is doing here. And it's no extent. The truth is that the target doesn't always follow a trend. Do we get that? The value doesn't always follow a trend. So I said 200 square feet could be equals to $2,000. 300 could be equals to 10,000 exactly. 500 could be about 2,500. So you can see that now this is now quite difficult for us to start. We can do it, but it's quite difficult for us to start computing this because we can see that there's really, at least from plain sight, I can't see any trend here within this. From 200 to 22,000, but 300 was about 10,000. 500 came down and no. So I can use like a linear regression to learn a pattern or what is joining this. Definitely, I'll have more data points than this actually. But this is just an idea of what the kind of data could be. So I can't see a trend here, but I'll plug it into this to learn something. And after it does the validation or whatnot, and I have like a good probability, then I can use this to, and I confirm that the model has generalized enough. So generalization is like the model being able to work with new sets of data that it did not see during training. So that is generalization there. Then I'll use this to predict something, let's say for 12,000 and so on and so forth. All right. So that is machine learning there. Do you get? But now when it comes to deep learning, and I want to use deep learning for this same task. Now in deep learning, I can put in the square feet, I can put in the location because location also comes into play when you are pricing your land or when you want to sell something. Location, I can put in the number of building, how popular it is, and whatnot as data points there. Now, if they are in words, you find a way to convert those words into number. But yeah, then I'll plug it here. All right. Then I can pick same linear model, regression model of here as my for the architecture I wanted to use for it to detect or for it to learn something. Now within this layer, now I was working with numbers, so that's why I'm easy to compute like a value here. But here, I'm not really working with only numbers. I have other things that I'm taking into play, different data points, different data set. Now, this guy here is learning a lot of things. Actually, two things, like the weight and the bias. But it's learning a lot of computation. And then it will now predict something. Once it predicts it, it will compare it with the actual value. Still the same way we have the test and training set in machine learning, same way you have the test and training. So it will compare. During training, this is what I got when I predicted it without looking at the target, without looking at the price that was specified there. How close is it? Is my error so large or is it so small? If it's so large, we run it again. Although you specify the number of training loops you get.
So
the main difference between the machine learning. Yeah? All right.
Before you go on, so for deep learning, we take in data, not just raw numbers now. We take in a whole lot of variables. We take in land, we take in facilities present in the area, because now we are using real estate as a point of explanation.
As an example,
so we take in, so for deep learning, a whole lot of variables that can affect the outcome of our our KPI. That's price. So what we want this model to do, or this deep learning model to do, is determine the price of a land, right?
Yeah, you're right.
Is that right? Yeah. So that's our key performance indicator. So we want to be able to accurately predict the price of a land. So it takes in all of these variables that can affect the pricing of the land, using real world constraints, right?
Yeah. I don't know if you're asking me or you're asking the audience, but yeah.
No, I'm talking to you. So I'm speaking on behalf of the entire audience.
Okay.
So I'm talking to you. Yeah. So since that is out of the way, I think the audience should have gotten something from what we just spoke about right now.
Okay. All right. So I think he asked one more thing that we should like now round it off or summarize the difference between like the normal ML and the deep learning. And so from the normal for normal machine learning, there is really no black box because you can compute that by hand, although it take you a long time to do this prediction. But for deep learning and the kind of data you work with are like normal data that you can easily use. When it comes to classification, it's a well, there's a kind of nuance to what I just said there, but you can just use that as the difference. Then when it comes to deep learning, you have this particular layer. If, in fact, in this image I have, you call it hidden layer. You don't technically know how it's learning the pattern. Yes, you give it the architecture to follow, but you don't know how it's arrived at that pattern that it's using to predict, if that makes sense. So in machine learning, you can even by hand get your model and create the model yourself. But when it comes to deep learning, what is going on in between the input and the output is kind of like a black box. And the reason for this, now this will now, I want to confirm if Martin understand. Okay, he said it makes sense now. All right, so I want to transition now into generative AI and why the normal machine learning can't, or we can't use this when it comes to generative AI per se. So I'll scoot over to this. Now, generative AI, you have, I said the difference between the generative AI and the normal is that generative AI generating something new, like a new concept. Say I want to generate an image now. I'd say a man playing football on Mars or on the moon. Definitely, I don't know if NASA has gotten anybody playing football on the moon, but there's really nobody playing football on the moon.
The ball is going to go back to the sun.
Yeah, exactly. So, but then you can generate something new from that particular thing from just your prompt. So that's generative AI. That's why it's actually called generative. We are generating something new out of just prompt. Now, prompt could be text, it could be images, and so on and so forth. Now, for Copilot, ChatGPT, how we talk to LLM. LLM will be our case study before because I know I've spoken a lot here today.
Don't worry, we're learning a lot.
All right, then let me just talk a bit about large language model. All right, I'll go back to the analogy I gave at the start. How do we learn new concepts? We've established that we use data to learn those new concepts, exactly the same way models work. Now, just think of this as you. Now, think of this as you. And sorry,
putting myself in the position of a deep learning algorithm. So
I'll move this here. All right. So I still want to have like tried programming there. So now we've fought the battle between ML and deep learning now. And this is tried and this then LLM is like our case study. Now, all right. I lost my train of thought there. Okay, I'm back now. When I'm building an application, that tells about the current news and gives current affairs basically. And I want this to tell me when I'm in Nigeria. So when Nigerian get the independence. Now in this, I'm going to put something like this. If say asked Nigeria independence, then say 1960 bar. But with this guy here, I'm giving it like a book, or I'll give it like a very, very big data, or even small data that contains the history of Nigeria. Now, seeing this, I was specific about this. I said, I've already told that, oh, this is the answer, 1960. But with this guy, I'm not telling you the answer. I'm giving it like a whole lot of data for you to learn. Now that data, how does it now? How does an LLM know what to give me back? Now there are a lot of processes that go into it, and I'll just skim through them. Now you have things called the tokenization. We have things called the tokenization. There's an interesting part I want to get to, and how like they understand the mixed words together. That's why that's why I brought this up, so that you would know that how does it know how to predict what I want it to do? That's my main goal. All right, so this I told you the answer. This guy, I don't give it the answer, but I already give it like one big textbook for it to learn. Now, each of these texts, you can think of them as, at least what the computer sees, it sees them as, yeah, sees it as what we call tokens. So this is an example. This word is in itself is not a token. So you need to like split them into different portions. So now if would be one token. There are different kind of tokenization. We have the whole word tokenization, the subwords, and single characters. But we'll do subwords since that's what this would be asked now, not asked. So ask, asked in English, past tense of ask is asked, something like that. So the root word is actually ask, not asked. So do you have like similar value then? Nigeria, let's just have this here. So now each of these words, computers do not understand words, they understand numbers. Now each of these words will be assigned their numeric value. Actually, they'll be assigned vectors. What is a vector? You can just think of vector as like a single list of numbers. Would that be a right word? All right, for simplification, let's just say yes. So this would be an example of a vector here. Something like this. Yeah. So now imagine each of these guys have like numbers associated with them. Now these numbers. I can have like a bag of words so I can have like a dictionary of this where I map each of these words to number at that process. So once this is now mapped, mapped to each of the value, then there's something called you need to get the encoding. So you can think of this also as an encoding here. They need to get their positional encoding because of where they come or where they occur actually matter. I'm trying not to get too technical. Please, if you don't understand, just bring me back. I know I might miss a lot of things. Just bring me back, please. I don't want to like be speaking jargon and not
continue.
learn anything at the end of the day.
Let them know how technical it is.
I think I'll go down on the technical scale so that AI is not scary at all. It's not scary at all, actually.
No science people will not run away.
It's not scary and it's not even complex. You just need to take your time. Like I said, within this 1 hour, 30 minutes, I won't be able to explain everything. So it's normal if you don't like get, but if there's anything that you feel interested in and you want me to go back, I will definitely go back. So we have the positional encoding here. Actually, there's a formula to this. It's similar to the linear regression formula that we have, but in this case now it's actually the weights. We have the softmax function and this plus the bias. So, yeah, something like this. Actually, this I can see call this X transpose. Something similar to that, but don't mind that don't mind that formula. Don't mind that formula. All right,
that one is for STEM guys.
All right then. So once I've been able to vectorize this and I've gotten the positional encoding for this. Now, where do positional encoding, like I said, is where do each of these words appear? Because in English, even in grammar, when you take anything English, the words where the location of a word is actually important in that sentence for it to make sense. So I can have something like what can I use? Okay, let's use this one. If asked Nigeria independent, something like this. I can have something like independence if asked Nigeria. So the position might know that didn't really make sense. But this makes sense. So you can see why it actually matters. The arrangement of words matter. If I move this here, if Nigeria asked independent, Nigeria now is seen as like an object, like an entity. itself that is asking what is independent. So this is more like a phrase now.
Yeah.
All right, so you can see why the positional encoding is important. Now you now have something called the self-attention. What that is just trying to see is that each word have like a relationship. Now we know that the position matters, but each of the words, there's a reason why I put asked after if. There's a reason why I put Nigeria after asked, and there was a reason why I put independence after Nigeria. There's a reason why this came after this. There's a reason why this came after this. There's a reason why this came after this. And there's even a reason why all these are used in this particular sentence.
All this now
so it's to show that there is
for the traditional programming method.
No. This deep learning now. This is not traditional. Traditional was that I told it what to do.
Yes,
exactly. I told it. I'm just trying to. Yeah, I'm just trying to demystify how the LLMs work, per se, or how they understand or they train address. So, if there's anything you take out, with the position of the word in the sentence matter, and also the relationship of each of these words, they matter. All right. So then, with the architecture, with the transformer architecture, it runs the training. So now that input for the data I told you does this computation here. Now, all these are done these are like pre-processing steps per se. Does the computation here and then gives you an output. Do that same training again until you are satisfied with the result that it gets. So when you want to ask ChatGPT a question, it does something similar to what we've talked about here. Encodes breaks down the sentence into tokens, then encodes it before it sends it into the transformer architecture. All right, before you get an output. So you can see that the deep learning actually is a higher complexity when it comes to, as opposed to machine learning rather. So it's a higher complexity as opposed to machine learning because we're trying to mimic human intelligence. We are very, very complex beings. Our brain is like the most complex thing about our body. It's very, very complex. Even as I'm talking, I'm firing neurons in my head. I mean, a lot of neurons are going in my head. I don't even know what they are doing, but I know they are doing something. That's why I'm able to talk.
They are communicating and transferring information.
Exactly. Yeah, exactly. So, and that's oh, sorry, my camera is out. So I'll continue without the camera. All right. So a lot of things has been happening within the hidden layer. Then you ask yourself, all right, okay, why did we go into deep learning and why is this important? Now this is because when you want to generate, we generate things. If I have an idea, if I want to sketch a person, a footballer playing football on the moon, I've not seen it before, but I can imagine that, I can create that, even though it's not real. Do you understand? Even though it's not real, I can do that. But traditional ML, this guy here, it can't really do that because it has not, what's it called? Don't let me give that kind of analogy because it will just be more complex since deep learning is like a subset. So let me just go into deep learning directly. So for deep learning too, it does something similar to that. And that will lead us to generate image generation. The most common method of image generation is actually diffusion. That's what is popular now. And real quick, the way diffusion works is start from normal noise, and then it should remove those noise to give you the generated the image you want, or the image it thinks you want. And but yeah, so I hope I've been able to.
For that image generation, when DALL-E and all these other image generators, you know, there's realistic. I guess it's more of DALL-E, or it's more of DALL-E that asks you if you want to use diffusion or whatever else option that is available. But I think now that you mentioned it, that it's a form of subtraction. That's how they built that model.
Yeah. If you can see my screen, I can just show you a quick demo. It's actually fun. So this is an image. DALL-E is actually it uses a diffusion architecture. Most of the image generation.
You know what? Share the font side. So people can have some fun.
The what? Okay.
Share
I'll do
the
that
font side. That was DALL-E. Yeah.
All right. So when I was learning image generation, it just made me understand how we as humans too tend to create things out of nothing. So I have dot. So when you put in your prompt, a man playing football on the moon, that list starts with, or any diffusion model starts with a noisy image. So say the image you want is 1024 by 1024, a square or whatnot. They start from the noisy image. Now, during the training process, it had already learned what these images look like. So say, for example, there is somebody playing football that has been labeled as that, and then to try and remove the noise, it's called denoising actually. So, sorry, one moment. I like to visualize things a lot. Sorry if you don't like it. I'm a very, very visual person. During training, here's what it's doing. Starting from noise. It starts from the original image, then begins to add noise to that image. So imagine this is one image. It has small noise here. It now adds extra noise here. It adds extra noise here, add extra noise here. Now, who knows why it's adding noise? Let me just throw a pop quiz out there. Why is it adding noise to the image?
I don't know. Give it color.
No, it's not because of color. It's because it's trying to calculate. The noise are random at first, but it learns. I have my camera messing up. Sorry for that. Okay, so it is actually that noise it is learning. The application of that noise is how it's actually learning how to generate images. Do you get? So it knows that this is a cat. This is a picture of a cat here. It adds noise here to this point. It learns something between that distribution. It adds more. Now, what specifies the amount of bubbles I'm having here is the number of inference. Like is the inference number. So if I have 20, this will be like 20. It follows what you call the Markov chain. So it doesn't go from here to here. It goes in sequential order. Yeah, but that's by the way. So it learns that. Then it now tries to reverse that process when learning. And when you are generating an image, it's reversing the process of, that's why it's called denoising. Now I told you that when it's learning, it's adding noise to the image. Then you now try to take that noise back to the image. So when you are generating, it is denoising, it is trying to remove noise based off that text that you've given it. The text is already in the vocabulary, and don't forget the encoding that we talked about. Actually, even in the image generation, you still have LLMs there that is doing the tokenization that tokenize the prompt, because we're still dealing with text too. You understand? So it tries to reverse this process of denoising. You can think of it as you trying to draw something from a white paper and then scribbling on it. But this one, instead of scribbling, is just removing noise to form a pattern. Do you understand? Or what it thinks that pattern is. So most of all these models are trained on like millions of data. Their parameters are always very big. Stable diffusion Excel is about 7 gigs. That's still small. Flux, if you've heard of Flux, is about I believe it's about 24 gigs at FP16 precision. That's like the precision of that model. Well, it's relatively small because of they want consumers to use it, but there are some that are like hundreds of gigs. Like LLMs in itself, those are like big. They are big boys. Except you want to distill there. All right, I know I've bored a lot of people here.
The data involved.
Yeah. No, they don't. The interesting thing is that these things, they don't memorize the answer. They memorize pattern. Please don't get that mixed up. They don't memorize the answer. They memorize pattern. Because if you memorize the answer, you are limited to. It's just like traditional programming. You're limited to what you can ask it.
Just be like garbage in, garbage out.
Exactly. Well, in a sense, it's garbage in, garbage out, because if it's depending on the data you give it, that it would tell you give you an answer. So if your data does not contain, say, Nigeria independence now, most LLM, they hallucinate. That's one of the bad things, or one of the disadvantage of not giving sufficient data. It will hallucinate, except even if you're explicit about telling it not to hallucinate. Oh, sorry, I said hallucination. The meaning of hallucination is when it tells you something that is wrong. Like it doesn't know that thing, but it still tries to tell you something. A model will always, like if you ask ChatGPT something, its prior, like GPT-2, at least now they're trying to work on the hallucination problem, but to try and give you something, even if it is wrong. You get? So if it was not in the training data, it might try to give you, and in some cases, it will just tell you that no. So it's still somewhat garbage in, garbage out. And that's why your data is very, very important. Like data is the life support of any AI model. if your data is biased, is skewed towards one thing, that's the same thing your AI model is going to give you. If your AI model is about animals, if your data is about animals, believe your AI model will be about animals because that's the kind of data you trained it with.
Yeah.
Do we understand? So data is very, 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 very crucial at every stage in any form of model, because that's the way we also function as humans. Yeah.
Mm-hmm.
I think I can go back to the slide now.
So can I ask a question?
I'll just think so. Yeah. Go on, please.
All right. So, are you saying that the model that is used to determine outcome or output is largely dependent on the data that is?
Yeah. Yes. The output
the
of the model, like I said. What do you say? Can you come again?
That means the model will always differ as a particular data type is fed.
No, it's not really, it's not fetching a data. That's it's not traditional programming. You might fetch a data from like a database or something like that, or like fetch it from somewhere. But like I said, it's learning a pattern. So they are like weights and pattern. They are weights and bias. Those are the patterns it learns. So it's not storing or the answers to the it's learning the patterns from those answers, if that makes sense. So like you said, your first question asks if the data is very, very crucial. If your data is not good, your model won't be good. So it's largely dependent on the data during the training phase. Do you get? Except you are now working with a RAG, like you're building a RAG system whereby you want it to be specialized on your own form of data. And then you can now have like your data being encoded somewhere, and then it's going to be pulling the results based off that. Do you get?
Yeah.
Most of these models, they're already trained on like petabytes of data. Like GPT alone is about 102 million parameters, about 400 and some trillion byte or something. Yeah, but it's very, very large. It's very, very large. So it has been trained on a lot of data. A lot of data. So without your data, it won't.
From my understanding, is
yeah, go on. I can't hear you.
I think it's his network, but
can you hear me?
let's go. All right, we can hear you now.
Okay. All right. So from my understanding now, that means the model I think I lost that. How do I answer this question? I'll rephrase. I'll ask again.
All right. Say.
I'm listening.
Hello, please. Can you hear me?
Yeah, I can hear you. Yes.
Yeah, please. Can I get a recap on everything you've said so far? I joined late, kind of.
Oh.
That,
okay.
Just give a
recap
on quickly. Just say a recap on what a model is, what machine learning is, what AI is, data learning, deep learning.
Okay. So I'll just give a recap. So we talked about a model. No, let's start with AI, since that's like the foundation. So we have artificial intelligence, and I give a definition as human intelligence, but exhibited by machines, or the ability for a machine to exhibit human intelligence. So they are just mimicking our own intelligence. What we would normally do, like a machine, is now trying to do it. Let me use the word try, because we are not yet at AGI yet. That is artificial general intelligence. All right. So now, but how do the AI now think? How do they exhibit this? How are they able to exhibit that? That's when we now touched on machine learning and deep learning. I talked about machine learning as the one that needs, you have both machine learning, deep learning, artificial intelligence in general needs data for it to learn or for it to be able to predict something. Just like we as humans, we need data before we can like do anything. We were taught a lot of things in preschool, high school, and all. That's how we are able to answer some questions now. So if we've not seen the concept, there's definitely no way we are able to answer it. So data is very, very crucial. We talked on machine learning, and I said that the difference between machine learning and deep learning is that machine learning, you yourself as a human, you understand how it's able to predict this particular thing. You understand the pattern essentially. But in deep learning, there's a there's a layer called the hidden layer where you don't really know what. Sometimes you might, sometimes most times you won't. It's like a black box, and inside that layer gives it like leeway to learn a lot of things, like work with, like I said, generate new things, generate new concepts. In machine learning, you're not really generating new concepts. You are predicting something based off trends. You get, but in deep learning, where you have generative AI and all, you can generate new things, and then we talked about large language models, diffusion models, large language models like things like your ChatGPT, Claude AI, or Microsoft Copilot, and the rest. While your diffusion models, what like used to generate images like DALL-E, Midjourney, Stable Diffusion, and so on.
So
I don't know if I
in
did
short,
justice to the recap.
yeah, okay. Let me give in short what I have learned and what I can say about all you've spoken about is now deep learning, large language models, machine learning, AI, all of them is just a huge data set. That is, we are feeding it a lot of information, whereby there's an algorithm um, that controls how it processes that information, that data, to analyze patterns. Now, that patterns that it analyzes and obtains from this data is the information. Like normal data is not really information. So now, to get information from the data, the deep learning algorithm and the large language models that are created analyzes patterns from the data that is being fed. And most times, this data goes up into thousands and thousands of megabytes and gigabytes. So basically, it's analyzing a lot of data and collecting information. This information are patterns being recognized in that data being fed to the system, which is now used for prediction. If that makes sense to any of you, you can just send a reaction. You can just drop a reaction. So I think
all right,
yeah.
So
So
I don't
we
have
can go
access
back
to the slides,
right?
so
You have
you
access to
can
the
share
slides.
that again.
Oh, let me share it. Let me share it again. So we'll continue now, since we've gone into the very technical side of artificial intelligence. Oh, my brain won't burst.
Yeah. Sorry for the tangents.
No. It's okay. You're using tangents again. You want to kill non-tech people. So, but like, yeah, it's cool. So they know, like tech is now a very open field. Even if you're not from a technical background, you can get into tech and you can do a lot of cool things with tech.
Yeah,
So,
and I wanted to advise that even if you don't want to learn the technicalities of AI and all, just have an understanding of it. It would really help, regardless of what career you're going or what you're doing, what you want to learn or what you want to study. Just learn at least the foundations. You can revisit maybe a recording or like go on YouTube to learn, even if it's the bare foundations of it. It really help out a lot. There are a lot of tasks, there are a lot of jobs in artificial intelligence, machine learning engineering itself that do not require you to write code. You can be a prompt engineer. Like if you understand how ChatGPT or large language models interpret prompts, just understanding, not even programming or coding out the architecture or whatnot. You can be employed to use that skills to like solve problems as a prompt engineer. There are a lot of
awesome.
career paths for even people that don't want to write code. Yeah, it's an
Awesome.
Interesting part. Yeah.
Awesome.
So all right.
Let's talk a bit. Let's talk a bit about these models in action. Just briefly, I'll just say from the slide, we put here that models can be used to train AI for speech recognition, for image analysis or image generation, predictive text, which is generative AI. So I know you've talked about it in depth. And
yeah,
well, this speech recognition, we use it in Siri, you use it in Google Assistant, use it in Copilot on your PC, use it in Alexa for smart homes and many other ways that we use speech recognition. Even in YouTube, text to speech, speech to text. When you even if you're typing to your friends and you decide to use your microphone, all of those things are AI in action. Then image analysis, we mostly, even when you're using Gemini, Copilot, or any other generative AI that is present now, like ChatGPT 2, you also use that when you give it an image and you say, oh, what does this mean? Maybe you're reading, let's say you're reading your school book and then you screenshot a passage from there and you feed it to the AI and say, can you explain this in depth? That's image analysis. It scans the entire text in that image and tries to make sense of what is in the image. There's a new feature in Android 14, Android 15, whereby you can screenshot your app screen, maybe on WhatsApp, and you screenshot the app screen and you can ask Gemini what is going on here. You understand? So that's part of image analysis. For predictive text, all of us, we use it a lot. We use Gemini, we use Copilot, we use ChatGPT a lot. So we know how this goes on for content writing, for just answering questions from school and using it in day-to-day activities. So models really are the, what do you call it? They are the baseline for AI, and it is what is powering all these AI tools we see out there, regardless of what it is. Right, Tega?
Yeah, yeah. The models are like the result of the training. So those are those are the things those are the patterns. Let me just say the word. Like I said, they are the computations that were learned is during the training process, and then you use that for your prediction or for your generation. Yeah. So
Awesome.
that's
Basically,
basically.
there's this clause
Yeah, go
here
on.
in the slide. Copilot, like this clause here in the slide. Copilot writes like a human because it learned from millions of us. you know. So that's the way the data is being gained and fed to the training model. So it's just a lot of data and a lot of training that gives us all these AI tools that we're seeing. All the background work, we don't see them, but we enjoy the end product. So I think that's awesome.
All right then.
Yeah. So I think with this, Tega, really appreciate your
All right.
deep dive. You took us from basic, basic machine learning concepts to advanced. You even came back again, like, let me just balance in the middle. Then you gave us some touches of STEM engineering concepts and keywords, So, and you tried your best to not make people's heads spin. So really, thank you for actually helping us with demystifying the technical side of AI. Really appreciate you, Ogehenetega. So I think with this, we'll move to the next place, which is where Abdulla is going to
Yes.
come in again and speak on a little bit about Copilot Studio. But before we go to you, Abdulla, I would also want to appreciate everyone that has been on this call this far. It's not easy taking out time like this to attend an event, more or less to even stay and learn. So I really appreciate everybody that is here. I give everyone a round of applause for staying true to this point. And I promise you, I know you've learned a lot, and I know you continue learning more. And we'll soon be ending the program. But before we end, you're going to learn the less technical side of the AI. We've
Sorry,
seen
David.
how technical it can be. Yeah.
Yeah, sorry, David. I
Some
don't
people
know.
want
There
to
are
speak.
hands up. Yeah, should we take it
Okay.
after or now?
No, let them talk. Yeah, Yetunde Omotosho, you can speak. Okay, a lot of people want to ask questions. Let them
And
come up and
good,
ask the
good
question.
afternoon. Can you hear me?
Good afternoon. Yeah,
Good
we can.
afternoon. Yeah, thank you for the program. I have some few questions. So I came in late, so I'm going through the presentation. And I came in when
Right.
Mr. Ogehenetega was doing some illustration, and
Okay.
to be candid, I don't quite understand. I'm going through the presentation
Yeah.
to see what is
Yeah.
going on. So I want to know
Yeah.
what are we going to do with it? And is there anything like,
Yeah.
so just let me know what we're going to do with it.
So yes, the reason why we first went to the technical side is because many times AI feels like a field that a lot of people shy away from because of the field it is technical and math intensive. When I say math intensive, a lot of mathematical concepts are being applied. So they shy away from AI. So the reason why we first went into the technical side was to demystify that part a bit and see that even though it's a little bit mathematical, there's mathematics inside, there's some concept inside that might scare you away. It's not that hard. Eh? So it just gave you an overview of all the processes that's involved in building an AI, from deep learning to machine learning to all the models and the trainings involved. And he let us understand that while it's a lot of processes working in between, it's something that has been made easy to do in this age and day. And the purpose of this program was to just get you that technical aspect, get you into the technical aspect a little, then show you that even without you knowing all that technical aspect, you can still do something cool with AI. You understand? So that's where we're going to be going into in the next half of this program. That is Copilot Studio. So just stay with us a little bit longer and you see all these concepts we've explained in action. All right. So to the next person who raised
Okay,
his
thank
hand.
you very much.
You're welcome here today. So I think that's Martins. Martins, you can unmute
All
and
right.
ask.
Thank you very much. Yeah, so thank you very much also, Ogehenetega. So it was a very, very insightful session. Yeah, so the first thing I want to ask is um do you like mentor people who are very interested in this aspect with ML, generative AI and all of that? That's one because I observed that while I was applying for the I applied for student ambassadorship, and one of the in the course part, this particular topics are like part of the course part. You understand, and it feels quite interesting. But you know, sometimes when you are doing these things on your own, you may just be lost and then just throw it away. In that sense, when you don't really know how to apply it and how to leverage the information. So, but with the way you sound quite you sound very very you know your stuff, and I feel if you have a way of putting people together to ensure that we like get to rub minds and also handle like real life stuff, see that oh this thing is not it's not like it sounds, it's not coding like it feels, it's not a lot of mathematics as it looks and all of that. So it could make it easy for people to actually like on board in that sense. That's the first that's my first feedback or something to say. Then the second thing I'll say is how do we connect it to apart from being in this session? Then the third thing I want to ask is can we get access to the slide you used? Yes.
Okay.
So that's
Yeah,
thank
the
you very much.
slide will be sent to the group. The slide will be sent to the WhatsApp group.
So for the first question, yeah, sorry, David, you want to say something before I go ahead?
Yeah, so the slide will be sent to the group, and the contact information of all the organizers of this event will be sent to the group too. So if you're on the WhatsApp group, you would see that. And if you're not on the WhatsApp group, Hariharan, can you share the invitation link for the WhatsApp group in the chat so that people that might not have joined can join? All right.
Okay.
All right. You do that.
So, okay. Yeah. Okay. I think David answered the last two questions. The first question about mentoring. Well, the mentoring is not. I don't do full-on mentoring. Like it's just when you have like a problem, you can reach out to me at any time, but not the proactive one that I'd reach out and do. But you can definitely reach out to me at all time. Then for learning also, and for you said you applied and you were not or they were asking some technical thing. No, Microsoft has like this learning platform, Microsoft Learn, where is for free for everybody, for students especially, where you can learn. In fact, some of these topics are covered there in depth, where you have hands-on learning. I think the thing you did, the quiz you took, that learning was from from same site, Microsoft Learn. So you can check out that platform, and if it's not still sufficient, then you can always reach out and see what we can do from there. I hope that's okay, Martins.
Yeah.
All right, then. Thank you, David.
Okay. Yeah. All right. Abdullah, it's your turn.
Yes, sir.
Yeah.
Thank you. All right, let's continue. Building with Copilot Studio. Wait, am I audible? Can you hear me?
Yeah, I can hear you.
All good, yeah? All right. Okay, so now let's talk about Microsoft Copilot Studio. It's a tool that lets you build your own AI without needing to code. So think of it as your AI, your rules. It's a low-code platform where you can create AI chatbots and assistants that fit your need. So here's why it's powerful. It's easy to use, just drag and drop, no coding needed. It's backed by Azure. It uses Microsoft's AI models for smart responses, and it works with Microsoft 365. It connects with Outlook, Teams, and other tools you already use. So businesses use it to create AI assistants that answers common questions, automate tasks, and it helps customers quickly. And today, you'll see how you can use it too. So why is Copilot Studio so special? The best part is that anyone can use it, like Tega said, and Faith, no coding is required. It makes AI simple and accessible for everyone. So with Copilot Studio, you can build AI-powered chatbots, assistants, and even creative tools without needing to have programming skills. It also works with the Microsoft ecosystem, as we talked about before, and even beyond that. So this means that generally AI creation is now for everyone, not just for developers. So let's see how we can use it in different ways. Copilot Studio for individuals. So let's say you want an AI personal assistant that helps you plan your week, from meetings to workouts to even reminding you your favorite Netflix show. So with Copilot Studio, you can create a bot that connects to Outlook to check your calendar, uses AI to suggest time slots for meetings, and sends automated reminders without you lifting a finger. And yeah, like I said before, no coding is required. Just drag, drop, and tell the AI what to do. It's like having a personal assistant that never takes a break. Yeah. Companies can use Copilot Studio to make work faster and easier. For example, businesses can create a chatbot that answers customers' FAQs 24/7. It handles orders automatically, reducing the waiting time, connects to company data, and works with Teams and Outlook for smooth communication. So instead of humans answering the same questions repeatedly, AI does the job, saving time and improving productivity. And finally, yeah. For students, Copilot Studio can be a game changer for us. Imagine having an AI that summarizes lecture notes or textbooks in seconds, turns long documents into key points or flashcards, and also it helps you prepare for exams faster. How? Just upload your notes, and Copilot Studio, using the Microsoft 365 integration, will generate a summary or a study guide with just a few clicks. So we'll go next by building your AI agent. I'll pass it on to Faith. Thank you.
Right. Thank you very much, Abdullah, for taking on that very important task, because we all have to know the applications of these technologies, because it helps us to understand and appreciate what these technologies bring to us. So for Copilot, I'll be sharing my screen in a few minutes, and we are going to, I'll take you through the journey using Microsoft Copilot Studio to build your own AI agent. And before we go, let's check out what an AI agent is. So an agent is a form of AI that simulates human conversation through a chat interface. Agents listen for keywords and phrases that relate to the library of known common customer issues, etc. So basically, like we said in the beginning, when Ogehenetega was taking us through the technical side, you know, I broke down that statement into tokens. So those tokens are like the keywords. They're the AI recognizes patterns based on its database and gives you a reply. So now you're going to be able to build an AI agent for whatever you like, whether it's for school or if it's for your company, if it's for your normal personal daily life or personal development, and you'll be able to do that with Copilot Studio. So we have also that, like he said, we said that Copilot Studio allows you to integrate with the 365 environment. It not only integrates with the 365 environment, you can connect your AI agent to Gmail, you can connect it to maybe your Zoho, you can connect it to WhatsApp. You know, let's say you want to build a generative, come in, please give me a minute. So let's say you want to build an AI bot, an AI agent that can reply to your WhatsApp messages for you. You know, you're busy, you don't want to stress yourself. There's a way to do that in Copilot Studio. So there's a way to do that in Copilot Studio. And while I won't go too deep into Copilot Studio today, I will share some resources to help you with that. But we'll go into the beginning part of Copilot Studio and how to add the triggers and actions that will allow you to perform majority or anything you want to do with Copilot Studio. And with that, let's get a little bit practical. Now, before I go into Copilot Studio, let me share my screen and show you an AI agent, which is Microsoft's own AI agent, an application of Copilot Studio. So I'm going to share my screen. I'm going to share my screen, share my screen. So, all right. Can you see my screen?
Hi, bro.
Yep. Okay. So let me go to now. I'm going to first search. So in your search bar, you can just search for Copilot, Microsoft Copilot, and you from there get access to Microsoft Copilot. So that's if you want to use Microsoft's own generative AI. Microsoft Copilot is Microsoft's own generative AI. So this is an agent. This is an agent. This is a Copilot agent. This one was built by Microsoft. This is their own generative AI, like other large language models out there. So you can also ask this one different questions, like I can be funny about it and say, how was your day? Probably let's see what it's gonna say. And based on whatever is in its all right, see what I said. He said, thanks for asking. My day isn't quite like yours. I don't experience time the way humans do. So you see that even though it was trained on data, they still put in constraints and all those kind of things when they were training this model. You see, it's telling you that awesome, yeah, I don't have a day, I don't experience day in the way humans do. So it can be funny, it can be doing anyhow, can do whatever I like. And you can use it for basically anything from business. Let's ask it, can you handle business or politics It's gonna talk. It's gonna say, I don't do politics. But let's see what it's gonna say. Politics and academics. Academic question. So now you see, I said before, an AI agent is like has a chat interface whereby you can communicate with a large language model. You don't see all the processes going on, but it gives you a response after, like, looking at all the most possible, like all possible responses, all possible responses it should give you. It will now bring it and give you the most accurate one depending on the question you asked. So, and now it said, absolutely, can assist you a wide range of topics from business to politics to academics and all the other things it said. Now, basically, this is just an application of AI. AI is being used in a whole lot of different ways. You can upload things when I sign in. You can upload images, you can upload documents, and some large language models might not allow you to upload documents, but I think a lot of them now allow you to upload documents. So so now I'll show you another tool. That's the tool that all this AI, AI Copilot Studio, and a lot of the Microsoft tools. This Azure is the tool that powers all of them. So I'll show you Microsoft Azure. It offers a lot of artificial intelligence resources that you can use to test out different AI applications, from cognitive AI to natural language processing to generative text. And so basically, voila for you. Let me change this from this one. So I want to show you Azure before I move on to Copilot Studio. If you are following me, you can send in the reactions. All right. Okay. So while that loads up, Azure is a portal. It's where Microsoft puts in a lot of different tools that you can use as a developer or a non-developer. It's a database. That's provision for database. That's provision for artificial intelligence applications, whether you can use to build your own image recognition systems and all. So while Azure loads, I'll move on to Copilot in a bit. And you can see the move by Microsoft. Copilot is now integrated into all their products and services. So with Copilot, you can easily use them to do basic stuff in any of Microsoft tools, from Microsoft Word to Microsoft Excel to Power Automate and a whole lot of other Microsoft products. So now you see Azure is like the backbone of the entire Microsoft ecosystem when it comes to AI and a lot of other different things. So from here you can create a resource. Now it test out all the different applications of AI that are available. So let's see cognitive services. That's for image processing. So so you can see Azure AI services, product image generation for training using. So you see that even without you knowing anything about AI, using all these tools, drag and drop, it's just drag and drop. Using all these tools, you can do a lot of deep learning, a lot of training of models to create your own personal AI. Even with custom computer vision, this computer vision, custom vision, it allows you to use images, train a model using images to build for your particular use case. Let's say you want to build a custom vision AI for waste identification, or you want to use it for jewelry identification. So you can do that with Azure. Azure allows you to do a lot of things with AI. I think there's still a lot more we can do in Azure. Let's see for speech. So speech services, this is another application of AI that allows you to convert speech to text, create transcription services, and other algorithms like that. So Azure is just a portal that Microsoft uses to give access to the public, many AI resources. So you can see here too on this left panel, there's a lot of application of AI. See Azure AI, Open AI. Now this one is integrating with ChatGPT as Azure Open AI services. If you want to integrate with ChatGPT's large language model, so you don't even need to program anything even before you can start using AI because of Microsoft Azure. So all these applications of AI, you see document intelligence, that is for probably creating AI for document scanning from invoices. You can train your models with invoices, with maybe letterhead, papers, and different type of documents, maybe PDFs of your school notes, etc. Then we have a translator. If you want to include the AI translator in any of your projects or apps. So now I'll go to the main content for today, which will be the customized Copilot Studio agent. I already have one, but like I said, I will take you from beginning to end. So this is Microsoft Copilot Studio. To get here, all you have to do is either click the link in the chat box, or you search Copilot Studio in your search bar on your browser, and that would allow you to gain access to the landing page for Copilot Studio. Then you can try it for free. While me, I'll sign in here and we'll get practical. While this goes, I'll show you something, because I'm sure there's a plus to using Copilot Studio. If you don't have a work email or a school email, you won't be able to access Copilot Studio. Yeah, because they allowed it to be currently for only organizations. So it's not open for personal emails. But that's not a problem. That does not have to stop you. And I noticed something that yes, even if you have a school email, it might not still work. So you can create your own work email, which is very simple to do. Thanks to Microsoft, you get a free work email. And let me reload this page. You get a free work email. If you are following, you can just send the reaction. All right, awesome. So all you have to do to get the free work email is search Microsoft 365 Business. So I know that a lot of people might not be on their PC, they might be on their phone. That's why when the recording is sent, you can still come along and check out do it. So when you search for Microsoft 365 Business and you click it, it's going to load up this next page. And then voila, you have the landing page for Microsoft 365. So we're going to try to create a work email, which you try for free. So we're just gonna try this guy here for free, but we're not actually going to be trying anything here. Just want to get the work email so we can register for Copilot Studio. So while that loads up, yes, this my guy has loaded up. Yep. So while I try to log in into my Copilot Studio here, I'm still going to show you the sign up for the Microsoft 365 so you can get a work email. Okay. Download. Abdullah. Abdullah.
Yeah, I'm here.
You're following, right? You get what I'm saying.
Yeah, I get what you're saying.
All right. Okay, so I already have a work email here, so I'm going to log out and create a new account instead. So if you there's a problem. I wanted to show you. Anyway, that's no issue. Let me use another profile. The reason why I'm using another profile is so that I can okay. So yeah, Copilot Studio has loaded up, but I'll come back to this. So yeah. That one loads up. Come up there around here. Okay. Since Copilot Studio has loaded up, I would go back to creating that in a few minutes. So it loads up faster. Anyway, right. So I'll go back to teaching you how to create a business account in a few minutes. So now this is Copilot Studio, where you can create your own personal AI agent. And you see that when you have logged in, and you created your account, you'll be able to access this interface too. You'll be able to do like, so this is something I created, I think, yesterday. So I'll let create a startup ideation assistant. I'll show you that after I walk you through the steps of creating something of your own. So let's go for this. We can create, click on create, and now we're going to create a new agent. You see that there are templates here if you want to just follow any of these templates, depending on what you want to use. You see there are some that are telling you coming soon. Microsoft will release that soon. But let's create our own. I don't know if anyone from the audience can suggest what type of agent do you want us to create. Anyone from the audience, you want to suggest what type of agent we should create? Anyone? Okay. Well, no one is replying.
Do you want me to suggest?
You can. Yeah, you can.
All right. How about an agent to summarize notes?
Okay.
Since we're all
Like school
students here.
notes.
Yeah. Is that possible?
Yeah, definitely.
All right.
See, it's now what we're doing is this Copilot Studio now, we want to create our own agent. All we are doing now is feeding in data. So it will now, from this data, it will ask us a couple of prompts, as you see, that will allow it to know what type of data it should gather to train its database or its model. Let's use model. So I want to create an agent to summarize my school textbooks and materials. So yeah, so very easy, very simple. You don't have to stress yourself. You don't even need to know anything. Just need Copilot Studio, and you know what you want. So it's asking now. Great. Now let's determine a name for your agent. How about textbook summarizer? Well, I don't like the name. Do you want to suggest a name? My notes. Are we? Yeah, pocket notes. You know, how does pocket notes sound? It's not bad.
Yeah, it's not bad.
So
That's good.
let's name
That's
it.
good.
Let's name it. Let's name it pocket notes and go. So now saying let's refine the instruction for pocket notes. First, let's define what pocket notes should do. For example, it could summarize textbooks and materials, provide concise notes, and highlight key points. What specific action or behavior should pocket notes perform? All right, so now we are going to give it more constraints on what type of actions you want it to do. So I want your on pocket notes to be able to accept the upload of my PDFs and images of my textbook materials and class notes. And use this to generate flashcards, summarize the scope of my course materials and resources. Can tell it to do whatever, let's say, and generate questions. And likely, let me say, likely questions that will help me in very important aspects of my material. Of course, my materials. So now we've told this AI agent, or now we are in the process of building an AI agent. This is the process of feeding in the data so that the model can be trained based on our specific request. So now this is our constraint. This is the scope of which we want the model to be trained. We've defined the required output for this model, and we asked that after uploading PDFs, images of school textbooks and materials and class notes, that it should generate flashcards. It should summarize the scope of course materials and resources and generate likely questions that would help retain very important aspects of my materials or coursework. So we've given it the input, the expected input, and the expected output. Now the rest is going to do it for us. Next, let's define any limitations or boundary for pocket notes. For example, should it only summarize specific types of materials, or are there any restrictions on the length or format of upload? Now, the reason why it's asking this is so that like it can know the scope and boundaries that it shouldn't exceed, and so that it can allocate the amount of, it can know how much resources to allocate for this particular agent. Do you understand? So now let's tell it just summarize everything. Let's tell it to summarize everything. As for restrictions, accept restrictions. Tell it to accept major formats. Accept only the most common formats for images as PNG. You can now give it PNG, JPEG. So then for PDF, the upload size shouldn't be any file should now be more than 20 MB. Okay, let's go. Let's see what it does with that. So if you are following, can I see a reaction? Yeah. So now you see, in just a few steps, we almost set up our AI agents. We're building our own chatbots. You're building your own AI agents, more like your own personal assistant. So the agent pocket notes now set up to summarize your school textbooks and materials, generate flashcards, highlight key points, and create likely questions for better retention. It's now asking, would you like to add any publicly accessible website or data sources for pocket notes? This step is optional. Let's see. YouTube.com, YouTube for reference to possible videos that might help me understand the topic better. Then also we can have which sites we have maybe ResearchGate. ResearchGate. Those two. So additional data sources that you can use to help out with your studies. If you know more, you can also add it depending on what you're doing. So next. All right. So now you see that we're just using prompts. We're almost done. The agent pocket notes is now set up with the specified functionalities and data sources. You can continue exploring Copilot Studio to add more functionalities to enhance the agent. If you add further refinement or changes, feel free to let me know. Well, now we are done. We have set up our own AI agents. You see, in just a couple of minutes, you have your own AI agent. So let's create it. And you can see over here on the right side, it's trying to compress the use, it's trying to compress the application of this AI agent. So it's telling us everything that this AI agent will and will not do. That's like Pocket Notes is an agent designed to help students by summarizing their school textbooks and materials. It accepts uploads of PDFs and images in format of PNG and JPEG of school textbooks, understand, materials and class notes with a maximum file size of 20 MB. It generates flashcards, summarizes the scope of course materials and resources, and creates likely questions to help retain important aspects of material of coursework. So it told us basically the description of what course note is, a big pocket note is. So he now further broke it down into summaries so that you can see in bullet points what pocket notes will be doing. Then it's saying that get its knowledge from YouTube, blah blah blah. You understand? So let's go create. So that will take a bit, not too long, but it shouldn't take too much time. So everyone in the audience, with this, have you been able to see how easy it is to create your own agent, your own AI agent? And I see a reaction. Yeah. All right. So we've set up our own agents while it's loading. I would love to switch back to teaching you how to get your Microsoft Work email. But I think that will be the last thing I'll do. All right. So our agent is currently in test mode. We've not published it. We'll publish it. Publishing it will allow you to access it and use it anywhere. Probably you want to use it in your own app, or you want to use it in your own website, or you want to use it in your e-commerce store, or you want to use it anywhere you want to use it. It will give you an API you can use, basically. Or you can use it from the Copilot app. Or if you can build the Power Apps application for yourself, whereby you can also embed it in it. So, all right, this is our guy. Pocket Notes. Say hello, I'm Pocket Notes, a virtual assistant. Just so you are aware, I sometimes use AI to answer your questions. If you provided a website during creation, try asking me more about it. Next, try giving me some more knowledge by setting up generative AI. No. So we can add a PDF and ask it to, so we can test it. Wow, this is loading up. Okay. All right, so all right, let's get some. Let's take this guy. All these guys. Let's upload it. Those guys. Anyway, let's put it to attachment. Can you help me out? I can't read this entire thing. I want to this guys. All right, so let's send it and see what's going on. So it's uploading it. It's uploading it. While it uploads it, let's check out this place. Now, this is where, if you look at this left, this is where you can do some more configuration. Like you can add an icon to it here. Like if you wanted to add an icon, you can change this icon to something of your own. If you have any icons you want to put, let me show it. So you see, when I press edit, let you edit the name of the AI agent. You can edit the description if it's not sounding right enough for you. And you can change the icon. When you click it, if you have an icon, JPEG, PNG, most likely use PNG. You would upload it and the icon will change. So now that's for that. If you wanted to add a knowledge base, you can also add from here. You can add knowledge. Maybe you have new websites that you want to add to it. You can add it here. And for actions and triggers. Now this is for more customization. I want to give AI agents even more accessibility. Let's see what kind of triggers you can add. Yeah, turn it on.
Excuse me, Faith.
Yeah.
Yeah, I'm really sorry, but as you know, I'm fasting and I have to go break my fast.
Yes,
So
definitely.
I think I'll have to leave the meeting.
No problem, Abdullah. Thank you for staying with us and helping us
course,
out
of
throughout
course.
this meeting.
Yeah.
And
Thank you
happy
for having me.
Ramadan.
It's a pleasure.
Yeah.
Thank you so
yeah.
much. I appreciate
Same
it,
here.
mate. Right.
Definitely.
Thank the audience too.
Share
Yeah.
LinkedIn details, and
For sure.
I'll
I
see
will
you
do
next
that.
up. All right.
I'll see you soon, yeah?
All right. Thanks a lot.
All right,
Yes.
everyone. Thank
Happy
you for your time.
celebrations.
Thank you. Take
Yes.
care.
Happy celebrations.
Thank you,
Right.
mate. Thank you.
So, yeah. So you can add a trigger whereby you can connect your AI model to a whole lot of Microsoft services, Microsoft Forms, OneDrive for business, SharePoint, Gmail, Power BI. Now, the use case of these triggers is like now, let's say you upload a new file to your OneDrive. Let's say you upload a new file to your OneDrive, you can set up a trigger that when a new file is created, let's say maybe you attach it to a particular folder in your OneDrive. Maybe that's where you save your class notes. So immediately you do that, you can now say that once that file is uploaded, let it summarize that file for you, send you an email, and tell you what that file is about. So even without you coming to use your AI, you can set up these triggers to even to increase the usefulness of your AI agents. We're not going to go deep into that today. So actions. This is where you tell it that all right, after the trigger has been set up, that is, this is a bit of Power Automate in here. All this part is Power Automate. So it's allowing you to automate a lot of tasks that you can do with your AI. And Power Automate is another Microsoft product. So you can add new actions. You probably say it should describe blah blah blah. I want to do. You can create a new Power Automate flow, or you upload a skill. Now for this upload skill, you're going to be utilizing those resources from Azure. I showed you Azure a while back. So you can add cognitive AI services that lets you scan images of your notes immediately and use it to generate flashcards for your AI model. Or you had speech recognition service to your AI model, to your AI agent, and a lot of different other skills that are available from the Azure resource. So with that, you can do a whole lot with Copilot Studio. You see, we're done with this guy. See what's generated. Said now we're going back to testing of the agent. Said you can create online and offline flashcards using a web-based application called Cram blah blah blah. All right, so let me say I can add that guy as. Okay, well we have to train this model even more. Let me see. I had even more knowledge base. Yeah, you can add. I need to have to check for the websites. So basically, you can add that to it. You can add it.
Oh no. This much. Like beginning of all these steps. It was my first day. Yes, you don't fund. You watch.
So why that at? And I ask that. All right, man.
Wow.
When will it forward?
Yeah, well, okay, I have to connect it to some other things. Yeah, you can manage the connections. But when I build it, for this application of Copilot Studio, there's a lot of connections we have to actually make it function more properly. Let me save this first. I'm going to show you the one I built yesterday. That one was for startup ideation. So it's more easy to set up. And you don't really have to connect to so many different services for it to function well. So this one, all I did to set up this particular assistant was just connect it to some particular websites, and which allows me, and I gave it the constraint to creating a startup, like all the processes involved in creating a startup. I used it Y Combinator as a reference, so that like anytime you ask it a question, it can format all you need using that template from Y Combinator. So now let's say if I have an idea about so so it will give you a list of different ideas you can use for your startup.
I found out something. Sorry. No, like my bank.
You can automate all of these processes because I've not added obvious triggers and actions. This is just showing you that you can create your own generative AI, your own AI agent without even having to code. You just use Copilot Studio. So from there you can publish. Then let's go back to if you wanted to create your own. If you want to create your own, like working mail. Before I now round up. So, yes? After you get to the Microsoft 365 business, you can, once that is loaded up, you can go for try for free. And once you click try for free, you open up a form page.
I think my crouching is weak.
Yes, because it's like cloud, wait for them to come up that shoot.
On the front page, form is loading up.
Yeah, kind of 9159 9159 43255.
Oh, hello, bro.
Yeah.
I was going to do one time, so I wanted to crouch and be moving on crouch.
20 minutes forward.
Using that aim.
Yeah, it's slow. It's taking time to load. All right, so it has loaded up. So now, just follow this process of creating a work email. All you do is, after this form has loaded up, press next. Don't worry, you're not going to be paying anything. And you're not going to be subscribing for the free trial. Now, for now, let's just type in anything. It's not going to accept this. And ask you to create a work email. So it says, yeah, it looks like you need to create a new account. Let's get you started. So I'm going to change my email. So I'm going to set up a new account. I'm going to set up a new account. Let's call it. Let's not call it this because. So say. So you put in your phone number and company name. Put in the company name. Put in the company size. No website. Change the region to your country. Change the region to your country. I am in Nigeria, so I'll change it to Nigeria. And yep. So after that, you'll send a verification code. Give me a minute. This particular number is not currently with me. Right, so 1, 2, 3, 1, 2. Anyway, so send a verification to that number, you type it in. You can verify it. So after verifying, you create a password. Now this is creating a work email for you. So you see the username, David, then @ Now this is the domain they are giving you as your work email. Now this is Fadata. Yep, that's the name of the company I put. Let's change this. Fadata NG. .allmicrosoft.com. So this will be your domain name. This will be your work address, and then you can put in your password. So afterwards,
It's always mapping everything.
There is
the account is created, then you can use that to sign into Copilot Studio or any Microsoft product that needs work email. So the school email is not giving you access to it.
The best position is when you are back into a corner and the person is coming. So that you're running into the person, they are able to for you to come. You are following them that track.
So yeah, we're not paying for this. We're not paying for this. So now we already have our work email, so we can go back to Copilot Studio and log in with that. I already have one open here. So we're going to sign in. Sign in with the work email we just created. Yes, use a different account. It's another account. David at
You are much better target to understand.
Microsoft.com next. Your password.
Hello.
Hello. So and there you have it. You have your Microsoft Work account created. And you can use it to sign in to Copilot Studio.
When this gets over.
I actually didn't
stop him in a few minutes.
Because this is the one I'm going to play.
So you can use that to access Copilot Studio and any other Microsoft Business Suite application.
Because it's common.
Because
so with that, I think you've learned a thing or two about AI, you've learned a thing or two about Microsoft, you've learned a thing or two about models, and you can build your own AI chatbots without even having to code. You can use Copilot Studio, and I've taught you how to access it because even if you don't have a work email or a school email, you can create one for yourself using Microsoft 365 Business. And with that, I appreciate everybody that was able to make it here today. And I will make the recording of this program available for everyone. And also, I will be sharing out certificates to your emails. I really appreciate making it here today. I hope to see you soon again on another program. So, Hariharan, are you still on the call? Yeah. So, can you come and round up the session? Just a few words. Appreciation to everyone. Hariharan, can you just round up the session? A few words of appreciation. So everyone I'm ready to the call. Hariharan, are you still there?
That's the one I plugged in.
I think Hariharan is not available at you. So appreciations to everyone who made it to this meeting, and I really am glad you all stayed this long. I thank everyone and see you soon. This ends today's event, the episode 8 of the TEDx Beat Chennai series. Thank you everyone for coming. Have a nice day. All right.
Thank you all. Thank you guys.
Bye bye.
See you everyone.
Yeah.
with